Hello dear students, let us solve two numerical problems related to quantization of energy and Bohr's theory of hydrogen atom. First question is, the diagram shows the lowest four discrete energy levels of an atom. An electron in n is equal to 4 state makes transition to n is equal to 2 state, emitting a photon of wavelength 121.9 nanometer. Calculate the energy level of the fourth state and the momentum of the photon. This is the diagram in which energy of n is equal to 1 is minus 54.4 electron volt, energy of n is equal to 2 is minus 13.6 eV, energy of n is equal to 3 state is minus 6.04 electron volt, and energy of n is equal to 4 state is E4, which is to be calculated. The transition of electron from n is equal to fourth state to n is equal to second state has wavelength 121.9 nanometer. Now solution. Energy of emitted photon in electron volt will be, energy of this photon will be hf joule, and when it is divided by E, it becomes energy in electron volt. So E will be equal to hf upon E, which is h c upon lambda upon E, and putting the corresponding values we get E as 10.19 electron volt. Now energy of this photon will be equal to E4 minus E2, that is E will be equal to E4 minus E2, hence E4 will be equal to E2 plus E. E is 10.19 electron volt and E2 is minus 13.6 eV. So we get E4 as minus 3.41 electron volt. Second part, from de Broglie formula, lambda is equal to h upon p. So p will be equal to h upon lambda. H is Planck constant, this much value, and lambda is 121.9 into 10 to minus 9 meter. So on calculation we get momentum of photon as p is equal to 5.43 into 10 to minus 7 Newton second. Second question, if the shortest wavelength in Lyman series is 918 angstrom, then find the longest wavelength in the same series. Now we know 1 upon lambda is equal to r into 1 upon r into 1 upon n1 square minus 1 upon n2 square, where r is Rydberg constant. Also for Lyman series of spectrum of hydrogen atom, n1 is 1 and n2 is 2, 3, 4 up to infinity. So the wavelength will be maximum corresponding to n1 is equal to 1 and n2 is equal to 2, and wavelength will be minimum corresponding to n1 is equal to 1 and n2 is equal to infinity. Therefore 1 upon lambda max will be equal to r into 1 upon 1 square n1 square minus 1 upon n2 square, means 1 upon 2 square, which gives 1 upon lambda max as 3 upon 4 r. Hence lambda max will be equal to 4 upon 3 r. Suppose this is equation 1. Similarly, between n1 is equal to 1 and n2 is equal to infinity, we get 1 upon lambda minimum is equal to r into 1 upon 1 square minus 1 upon infinity square, which is equal to r into 1 minus 0 which is equal to r. So lambda minimum will be equal to 1 upon r. Equation 1 upon equation 2 gives lambda maximum upon lambda minimum as 4 by 3r upon 1 by r cancels out, and we get lambda max as 4 by 3. Lambda minimum has value 918 angstrom. So we get lambda max as 1224 angstrom.